very, very fast countdown timer. Hello, AJ.
Hey,
How are you
Darko.
doing, my friend?
I am great. The baby is crying. I have got 3 hours of sleep and I'm ready to do this.
As one does. Remember, caffeine
That's right.
makes it better, I think. They tell me.
Glad to be here. Thanks for the invite.
Thank you so much for coming. Hello, friends. Hello, Twitch. Hello, YouTube. Welcome to another edition of Serverless Office Hours. My name is not Julian Wood. My name is Darko, and I'm kind of fitting in today, this week, instead of Julian and the gang. But I do have the most amazing AJ joining me and us today here. And we're going to be doing some fun, rusty serverless shenanigans with some dogs and tracings and crates and other things. So if you're new here, welcome to the AWS Twitch channel. Welcome to the Serverless Land YouTube channel as well, I guess. And this is happening live, so we can see the chat. Please do drop your questions in chats. The Dirty Gall is saying, "Hey, hello, welcome, welcome, welcome." And yeah, AJ, hi, welcome. You've been part of the other show we've done in the past. I think one of our most successful episodes, I actually must say. So it's excellent to have you back.
Take that as a win. Thanks for inviting me back. It's good to be here. It's good to be back live on Twitch. I don't know if I've done this post baby.
You haven't streamed post baby Twitch?
No, not yet, but it's great to be back. I spent a couple of hours with Benjamin Pyle setting up a little demo app for everyone today, but we're going to try and recreate it from scratch, which I think is going to be a real adventure. So thank you, everyone, for joining us.
That's going to be fun.
Yeah. Should we get started? Should we jump in?
Yeah, let's go. But tell us who you are and why should we listen to you?
Sorry, quick intro. I'm AJ Seibenberg. I'm a staff engineer at Datadog. I work on serverless observability. So if you're using Lambda, Fargate, ECS, you're using Google Cloud Run, Azure App Services, any of those kind of scaled container or function as a service sort of platforms. We create the telemetry and the observability tools for those things, and then you can deploy them into your applications. So I work on a bunch of open source code. We'll look at some today. And we ship libraries that then you can then install and use to get some sweet traces and logs and metrics and all that good stuff.
Amazing. Shout outs to Benjamin as well.
Yeah,
Benjamin, a fan of the show as well. Amazing. Great. Let's get into it. Let's open up the thing. So we're going to be launching this. We're going to be doing some tracing with what is it called? With Datadog and Lambda and Rust. So Daniel is saying your mic volume is a little low compared to Darko's.
Oh yeah, let me adjust that in StreamYard really fast. Okay. Audio. Okay, we're going to give it a good 50% bump. Hopefully this is okay. Can everyone hear me okay still? I look. Oh, this must have been a YouTube chat, not Twitch chat.
Yeah, it's a YouTube chat. So it's Danilo. Yeah, I actually put my microphone to automatic right now, so it may be better. So now we may be a bit more equal because my microphone was just bumped all the way up.
All right.
So it could also be me.
Cool. I will start a screen share here and we can talk through what we got. So a little bit about Rust and why it's good for Lambda. If you haven't written any Rust before, don't be afraid. I recently picked it up for a project, and in about 4 months was able to ship something we feel pretty good about. So you can do this. I believe in you. Everyone can do this. Everyone can pick up this language and use it. We like it in Lambda for a couple of really important reasons. Probably the first is from like a safety standpoint. Right now in Rust, you can more or less guarantee that you're not going to have things like a null pointer exception because Rust is going to force you to handle all of your memory yourself. That can be hard. That can be a challenge. The borrow checker can be a real pain. However, it's worth it, especially in Lambda, because we have these like very, very small functions with very, very limited resources, and the overhead of a garbage collector, like you would have in Go or in Python or JavaScript or .NET, can go away, and then you can actually reclaim that back. So there's actually a new blog post on Datadog's blog about time series indexing at scale. I'll plug that into Twitch chat, but it talks all about why we're using Rust for specific performance sensitive parts of our stack. So let's jump into this. I have a brand new directory. This is completely empty. We are going to create an application to grab some baseball statistics. Again, shout out Benjamin Pyle for helping me out with this, but we'll do a CDK init. Oh, actually we need two parts. We need our infra and we need our code. So let's, the code can just go here. We'll go back to that in a second. And then let's make our infra.
I wonder why is it baseball when Benjamin podded it? I was kind of expecting golf for it to be.
I think because he's using this like demo API that we'll use, and it's got baseball hit stats.
So we're going to be using CDK here for the actual infrastructure part of it. So
Correct.
CDK is going to be written in TypeScript, but the actual Lambda functions are going to be running somewhere in the cloud are going to be written in Rust. So
yeah, that's exactly right. And in order to support that, what we're going to use is a project called Cargo Lambda.
Cargo Lambda.
If you've not heard about Cargo Lambda,
I'll drop in a link to the chat as well.
yeah, great project. Shout out. I forget who works on this. Is this also one of David's projects? Yeah, it is. Okay, so David Calavera is everywhere in Rust and AWS.
Yes.
He's worked on a number of different tools. The crate for Lambda's HTTP, which we're going to use here in a second for the types and structs for interfacing with their HTTP libraries, along with this toolkit that plugs straight into Cargo. Cargo is Rust's package manager, similar to NPM or PyPy. It will allow you, it gives you like a CLI tool to manage dependencies and build and bundle applications. So Cargo Lambda will actually act as like a cross compiler for us, and it will help us build. Right now I'm on my M1 Mac. That is a ARM architecture. Cargo Lambda will help us like build for x86 or ARM in Lambda.
Yes.
Does a bunch of other stuff too. It can actually just deploy your function if you want to do that. We're plugging it into the CDK, which will allow the CDK to use this. So is it npm install cargo lambda? What is it?
Yes, it should be npm. So it's let me open up the documentation. So the doc says we could do brew, but you can use is it npm? I don't see an npm.
It's npm for the dependency into CDK.
Oh, CDK. Right.
Yeah.
Yes.
So we'll add that here. And then, okay, so now we should have a pretty standard project, right? We've got the bin, baseball stats, infra. This is where we're going to create our stack. And then we've got the lib and then baseball stats infra stack, which is here. So this is the code that defines our stack. We are going to create just a regular Lambda function. So, and then what we're going to have to do is go back out to the code directory and create a Rust project using Cargo. So everything will make sense, I promise.
Right.
Let's get this going here with the stack itself. So we need to import the Rust function.
Yes. So we're using a specific object called Rust function here, coming from the cargo Lambda module, right? So it's not your typical Lambda function, which is built into the CDK library as well, but this is coming from the Rust from the cargo Lambda module. So
yeah, exactly. And so now we got to, if you've done any CDK before, this will look familiar, but we'll create an API handler. And we pass. I keep doing this in my. Oh, we should talk about keyboards, Darko.
We should talk about the keyboards. Yeah. By the way, chat, we're both trying. Well, AJ is doing it. I'm still trying. Better. I'm still trying to use the keyboard. So we're both rocking these Kinesis Advantage keyboards because your code runs actually faster if you run it with this. If you write it with this keyboard, did you know that?
It does. Yeah,
it just runs faster. So the Lambda startup times are quite shorter if you run it with this keyboard. They're not. But yeah, it's. I'm actually fascinated how fast you manage to type in it. I haven't used it like quite extensively, so like it's me just trying my best. So.
Okay, so we've got this function, and I'm just going to add a function URL, and I'm not going to give it a path like Copilot's suggesting. I'm just going to give it an auth type, and this is suggested here, and then we need to AWS Lambda. Now this has an auth type none, so this will be like a public endpoint. Oh no, sorry, I got that wrong. Function URL.
Function URL, yes, and then auth type.
Auth type, there it is. Dot none. Okay, so. Yep. I'm confusing. The reason I'm confusing my enums is that this is TypeScript, and in a second we're going to write Rust, which has colons to delineate between options and enums.
Exactly.
So we'll get there. So just super quick recap to start. We've got an infra stack for our little baseball stats project. We have a API handler, which is going to be this Rust function. We're using this from Cargo Lambda. Shout out David again, everywhere in Rust in AWS. And we gave it a path. And it's got to be a fully qualified path. This is a little bit of a gotcha for me.
Yep.
So just keep that in mind. And I want to double check this too. So let's go. Okay. CD code, npwd. That looks good. OSS baseball stats code. Okay. We're in the right directory. Everything looks good here. So now what we have to do is call our module. So in the bin, actually we shouldn't need to, right? It should import it completely, right?
Yes,
yeah, it does
yes,
this.
yes.
Okay,
You
so
don't have
that's
to do
part of
anything. Yeah.
Okay. So, and I don't think we care about the source maps here. Okay. So I think we're actually good on infra for a second.
Okay.
Let's go to the other Tmux pane here, number 2, and let's create some code. What is it? Cargo init.
By the way, one of the ways I managed to use the manifest path for my Rust function is actually you can use you don't have to use the fully qualified domain name. You can use a relative path as well.
Oh, really?
So like when you say a relative path, you mean like starting from the root
like
of the
this
CDK
directory,
directory.
go one up. Yeah.
Yeah, so you can do from the root of the CDK directory. So it has to be like /code and then your function. So you have to go the whole thing. Yes.
Oh, that explains it. Okay, well, then you don't have to use the fully qualified path. I'm just a goof and I screwed it up, but I appreciate that.
You're not the goof. You just use the obvious way to do it. So
it worked, right? And then I moved
Yeah.
past it, and then I told everybody I was right. Okay, so we have got a Cargo Lambda. I think Cargo has like a quick start for this?
Okay.
Oh yeah, they do. Okay, so we should remove the init.
Yeah.
Oh yeah, no, it is. So it should be Cargo Lambda init. Okay, so rf dot. What?
Yeah.
rf src. Okay.
Yep.
So now we should be able to do. I think it's Cargo Lambda init. Cargo Lambda init.
Right.
Is this an HTTP function? So yes, we're gonna do HTTP function. It's gonna be a Lambda function URL, like we said before. Okay. Now, okay, so this is what I thought we get. We get a little bit of types.
Correct.
A few things that are helpful. We're going to change the package name again. I use the directory name, but we'll call it baseball stats.
Okay.
And then it's including this great library called Lambda HTTP. We're going to need that right away. And then it's including Tokyo.
Because you should always use it.
By the way, deep breath.
by the way, I've learned that it's not pronounced Tokyo.
It's Tokayo or
Tokayo. Yes.
Tokayo, yeah.
So yeah.
The problem is that I've heard it this way first, and I'm aware that it should be Tokayo, but I can't not.
I know. I agree. But it's also only using a single feature called macros, and that should be sufficient here, right?
Yeah.
Unless
exactly.
we're gonna go deeper into like
SDKs. we could talk about how Tokayo balances system threads with runtime threads, but I think the more important thing to think about here is what we have here is very similar to Node.js. Tokayo will start one system thread, and it will let us run a bunch of promises. In Rust, we call them futures, but you can sort of just think promises if you're a TypeScript or JavaScript developer. And it'll drop in that similar model, right? Where you have one actual process running on the system, and then it can concurrently execute and await multiple different IO paths or IO operations. And that's probably all we need to talk about for Tokyo now. So let's go and look at the actual code.
And by the way, it is absolutely, if you're going to ever use the AWS SDK, Tokayo is one of the most important libraries. You cannot use the AWS SDK without Tokayo because all of the SDK calls are asynchronous. So.
Yep. Yeah. Okay, so this is scary. I'm going to admit this. If you're new to this is scary. Like, why am I writing the word box here? That's scary. You know, why do I have this hashtag thing that's not a comment? It looks like a comment, but it's not. And then what are all of these ligatures around the function I'm sorry, the function arguments. Thankfully, we don't have any lifetimes to deal with here. We can talk about that, but the most important thing, if you're brand new to Rust and today's your first exposure to it, is that instead of a garbage collector, all of the memory you allocate, like if we do let foo equal array and we create like some array of some, one, just like Copilot suggests, this array will be allocated onto the stack. And then once this function exits, that array
it's gone.
It's gone.
Yep.
So it's closure-based memory management until you start putting stuff on the heap and sharing it. And that's where the box comes in, and that gets a little bit different. And we won't get there in this stream. In fact, if we get anywhere near what I have planned today in the stream, I'll be stoked. So I'm just going to remove the comments to clear it up a little bit. But this is what we get right from init, and this should be ready to rock. It should say hello who from the Lambda function.
Exactly.
You can already see that Tokayo and Rust, the Cargo Lambda project, includes a tracing subscriber. We'll get into that in a second. What I want to do now is just see if this works. So support AWS profile equals personal. We'll go to my personal account. And then,
You
yeah,
can do CDK deploy. Huh?
I think we can just stand it up.
So what this is going to do, because you're using the Rust Cargo Lambda CDK module, it is going to actually build the Lambda function for you. Like it's going to compile the
Whoa.
application, and it was supposed
It
to
was
compile
supposed to.
the application.
Oh, I wonder if it's this path bug.
Is it a path bug?
This has happened to me before where cargo, no, it's not the path bug. What's going on now?
Failed to bundle error bash exited status 101. That's a
What did it do? It didn't like this.
beautiful error.
Yeah, lovely. Oh, I wonder if we need to, in here, let's try, whoa.
Just try cargo build, maybe, yeah?
Gotta do cargo lambda build, right?
Cargo Lambda, okay.
Because this will cross-compile it.
By the way, hello to Brazil from Daniel. Yeah, and Tony says 2 important lessons so far: coding in iTerm, it's in NeoVim, but yes, in iTerm can be efficient and has IntelliSense and Kinesis keyboard for development. Absolutely, yes. Do not go ahead and immediately go spend a lot of money on a Kinesis keyboard if you have not tried the split keyboard before. Try a split orthogonal keyboard before you buy this, because
Yeah, try it out first, for sure.
You may hate it, yeah.
How did I break this? glibc processed and exit successfully. Oh, let's try this. Let's get some debug logs from this. The cargo profile release build override. Okay, this might work now. I had a weird issue today with this. That environment variable fixed it, and it does look like it's working now that everything's compiling.
So the compilation did fail, not the CDK part as well, right? So
yeah, I think it's something on my system, and then once I go into the debug mode, it works fine. But it's compiled baseball stats now. We've got everything working.
Okay, good. Yeah, unlike your typical Lambda function that uses like Python or JavaScript, this has to be compiled. So what you're doing is you're actually shipping a binary over to the cloud where it's running. So not the actual code.
Yep.
So it needs to be able to successfully compile locally. And for example, as AJ is using like a ARM-based Mac, by default, it's going to compile as an ARM binary. But because of Cargo Lambda, it's going to also cross-compile to x86, depending on which platform you choose. By default, the Lambda platform is x86. You can change that to be an ARM platform, but the Cargo Lambda module is going to handle all of those things for you, so you don't have to worry about doing any sort of cross compilations. So
yeah, exactly. It will handle the fact that my destination target is running on a totally different instruction set and architecture than my laptop. It also just is going to be more consistent, right? If you're going to have multiple developers working on things. Okay, this stack is up. Let's go over to the AWS console. Okay. Lambda, and what do we call this? Baseball infra.
Baseball infra. Can you zoom in uncomfortably into
sure
that?
Can.
Thank you.
Okay, so we're running on Amazon Linux 2023, hashtag latest versions. You should be doing that. I also haven't shown this to people quite yet, but I'm also running, AWS has a account management feature. And it allows me to provision and go through multiple AWS accounts. So I've got multiple. I've got them set up, split. So I've got stuff on stream here, and then my actual important stuff in another account. Warrior Amp says, hypothetically speaking, let's say I have no experience with Rust. Can I still follow this? Yes. We are going to barely touch the surface of Rust as far as the real complex stuff goes. This is we're going to basically ship hello world in Rust. We're going to make an API call, going to get some data back, put it on the screen.
And I do encourage all of you folks, even Rust does seem daunting, but it's not. Once you get over the borrowing mechanism hump, you're good, right?
It was, like I said, we chose it for a project for the same reason I think lots of people are choosing it right now. And we did that 4 months ago, and we've shipped the project to production a few weeks ago. So it's like, and I had zero Rust experience prior to that at all.
Exactly.
This is possible. You can do this.
Yeah. First time I ever wrote Rust was this year, January this year. I started learning Rust from the book, and I have a package that multiple people use these days, which is fantastic. And I couldn't ever believe that would be the case, just because Rust gives you the confidence that your application will run.
Exactly. And I'll just show you, like for the folks just joining us who are new, here's the code that made this happen. Yeah. So we are going to grab the parameters called name, and we're going to slap them into this string format.
Right.
So we assign it to the variable who. You can sort of ignore the unwrap or for now. That just is error handling, and it's not
Yes.
great error handling because right now this would
It's
crash
horrible. Yes.
if something is broken. But that's okay. And then we're going to format it here, and then we just put it into the
Yeah.
body, and it's rendering HTML. It's
Yeah.
not rendering JSON.
There's
So
there's not a lot to it. Again, super simple. It's just typical hello world lambda function where it just returns something based off the parameter. Now the parameter you passed in the URL, you may not see it here, but basically at the end of his URL there's a question mark, name equals Darko.
yeah, it's
And
a little teeny.
yeah,
Sorry.
it's super teeny tiny. Yeah, but like that's how he's passing the parameter here. So
Yep. So, okay, this is working. That's great. So the next thing we should do is we should add some tracing support. So
what is tracing? First of all, let's talk about what is
Yeah,
tracing. Because
absolutely.
folks need
Absolutely.
to know.
So when it comes to application performance monitoring or APM, one of the things we really look for is how long did individual aspects of a function operation take? How long did something take to happen? When you have an application that is running in a production environment and maybe, you have to go in and call 2 or 3 different microservices, maybe you have to go and update some data in a database, you may have to push something into a queue and then return some information to a user. That's a lot of different parts that can go wrong. And that in those individual components all could have different lengths of time, different amounts of time that they could take. So what tracing allows us to do is see how long each of those takes. Here's like an example trace. It looks bad because my screen is super zoomed in. But right now we don't have, it's just like hello world. It's not doing anything. This is like an earlier example. I'm going to have to, I don't think it's going to like being this zoomed in.
So feel free to zoom out as much as it makes sense. So
yeah, 1 second. Let me get back to the actual.
We're dealing with ultra wide screens, folks, here. That is usually the challenge for live streaming. So can I make this slightly? Is this
1 second?
better?
Okay.
I don't know.
So there we go. So you can see there's just like an invoke and then the function handler, and then there's some metadata. So there's not a lot here, and we'll jump in and we'll show more. But this, you can imagine if we have like a database or a queue, like we had said, these will start to show up as spans. So that's sort of the advantage you get with tracing, where you can actually see how long your function code in this example or your application code takes. So let's add it. There's a few things we have to do to add, and I have to go and reference my notes here so I don't screw this up.
So while you're doing that, just kind of a tip here for folks. Tracing is not a mandatory feature of an application, but it definitely helps you out in 2 things at least. Number 1, troubleshooting, actually finding where your things fails, where does it actually break during your execution, and 2, benchmarking, understanding that specific parts, specific elements of your application, specific calls it makes take an ungodly amount of time for some reason, right? So understanding those things can only be done with some level of tracing. Now, that was done in the past by doing something very, very manual and just timing stuff, and you should not do that. There's plenty of tools out there that can help you, something like Datadog, X-Ray, and a whole bunch of other stuff.
Yep. Yeah, absolutely. Okay, so it's going to start to yell at me. That's okay. There's the first thing we want to do is actually instrument our function. So we can do that with the macro we just imported called instrument.
Okay.
And what that will do is actually wrap this function. If you can imagine, what all instrument is doing something similar to this in pseudocode. It's saying start time equals now, and then this function runs, and then it says, okay, end time equals now, and then it does a subtraction, and it tells you how long that took.
Okay.
That's effectively what we're getting out of the instrument macro here.
Nice.
And then there's a few other parts that are going to go into this. Let's add...
is that all you need? Is that just you need to add an instrument macro?
Yeah, it's kind of neat. I need
amazing.
to, 1 second, I need to...
So while you're doing that, James is asking about borrowing. Let's discuss borrowing. Basically, borrowing means with your function, the variable value is owned by the variable. If the function finishes running variable, it will go out of scope. To use the variable, you need to clone it. Is that correct? Yes, technically. Basically, what happens is only one thing can use the value at one time. Well, depends. But like variable can be both mutable and immutable. By default, they're not mutable, right? You can't change the variables, right? If something else, a function takes the variable, nothing else has access to that variable until the function returns the variable or does something else with it, right? There's a whole thing about it. It's just a safe memory management, and it has to do with storing data on the heap versus the stack and all that fun stuff. So
yeah, and if you if you're new to the term stack or heap, the really crib note sort of easy way to think about it is the stack is going to be arguments local to any function you're in. So it's like just like a local variable, like I'm doing right here. I'm setting a service name. That's just a local variable. That is not going to leave this main function unless I actually pass it somewhere. And then you can also think of it in a performance sense of it's quick to allocate. Yep. It's quick to make space for. The heap can be shared with other parts of your program. It can live for a long time. It can outlive the execution of this function. It can outlive main. It can go and be used and shared by other things. With that comes concurrency controls, right? And if you're new to that term, that just means how do two processes that can independently execute access and share data safely. I think Go's mantra was like fearless concurrency, or was it? Is that Rust? I forget. One of the two.
One of the two. But Go is really good.
Also has very good concurrency controls. Yeah, and that's what the key takeaway that I wanted to have is that more modern languages are understanding that grappling with concurrency is the largest challenge when it comes to building safe and performant systems. So we tend towards systems now which specifically handle that with some amount of ergonomics. But not this, because we're just going to read an environment variable.
Exactly. Yeah, we don't hear about concurrency here too much, but still, you have to be. Rust forces you kind of to be memory safe, right? It's being forced upon you because you don't have a garbage collector here, and you have to manually manage memory by the means of borrowing, of the borrow checker. Yes. It is, again, you can always you can cop out always and use the .clone and just clone it to a different variable. You can do that, but that's less optimal.
So one of the other things about Rust is that error handling is explicit. So if you're not, if you're a programmer, you'd probably just recognize this as pseudocode, right? We're assigning a variable from a call that's getting an environment variable called DD service. This other part looks weird. Unwrap or. So unwrap is telling me that this call actually returns what's called a result. This result is an enum, and it either returns the string, which is successful, or it returns an error. And I have to handle the error part. So the string part is fine. We've assigned it. We're going to use it. The error part says, what are you going to do if this can't get this environment variable? And I've just set a default here. The other option, if we just did unwrap, like we talked about earlier, it would just panic and crash, which is totally valid in this case.
Or you can do the other one. There's a thing where you can propagate errors back, like to some other functions, right? Like you would, this is the main function, so you potentially wouldn't do it here. But like if this was a nested function, you can propagate errors throughout multiple nested functions to go all the way back and be handled somewhere else.
Yeah, which is super common with HTTP-based systems. Like that's exactly what you really want, right? Is like, I want to be able to say this deep thing in my trace failed, and I want to propagate that error back up. And that's key for tracing as well. So it kind of goes really well together.
Agreed. Okay, so what are you doing here? So you create a service name here, and this service name is going to be a tracer thing, right? It's just a
we're passing it to the tracer. So we're gonna create a trace pipeline using a crate called OpenTelemetry Datadog. Datadog, like the company, we don't own this. This is a community supported crate for OpenTelemetry, and it's part of the OpenTelemetry project. I think we've had Datadog employees contribute to it, so it's open source. But it is what we're going to use today for this demo. And we've got to just kind of set up some of the components. So we need a few things. First, we have a couple different API versions. So we'll do, we're not going to use version 2 because that is a LLM hallucination.
Okay.
We'll use
version, really?
Yeah, it is. It doesn't exist. It's 3 and 5 that we can do in this system. And then we need to set up the trace config. So we will do, I'm going to actually copy this from my example so I don't.
That's okay.
Get that
so while you're doing that, I want to answer something from Daniel. Like, I love Rust, but in my mind, its use of high performance or multi-threaded environments is really aligned with the use of AWS Lambda. Absolutely. The fastest way you can run Lambda these days is a Rust Lambda because it has very, very low startup times. It's just super, super, super fast. So it's not only for high performance backend systems and multi-threading. It can do a lot of things really, really fast. And as soon as you get your head around it, it's going to be the best thing you ever wrote.
Yeah. And that blog post I linked to earlier, we talk about how we had tuned a highly performant backend system to the point where 30% of our overhead was just garbage collection. And when you get there in Go, there isn't a whole lot more you can do. I mean, there is. Don't get me wrong. You can crack open the Go internals, like Felix, my coworker, who's worked on the compiler and does an incredible amount of work. But for people like me, it's sort of like a wall. Rust gives you that 30% back, which can matter. It's true if you have these like. If you don't have a high performance use case, there's still a lot of reasons to pick Rust. I think binary size is super important if you're working on an embedded system. If you compile Hello World in Go, it's going to be 5 to 10 megabytes just right off the gate because it's a big runtime. The benefit of the runtime, Go's runtime, is that it runs more or less everywhere and it contains basically everything you need. That's great. There's nothing wrong with that. Rust is going to be linked against like a glibc implementation, so it doesn't include its own like Go does. So you can link against Muscle, you can link against glibc. In this case, it's glibc. But there are a number of other cases that make it just a much smaller overall binary. And the reality is that because you have to do more manually, if you don't do those things, they don't show up in your binary. And that's one of the advantages. So binary size, a big one. And the second is just runtime safety. You can get a lot of guarantees with Rust. If you want something to go off and live and run for 100 years and you know it's going to work and be reliable, Rust is a great choice.
Yes.
Exactly. Darko and I were talking before stream, but I would say if I was going to start a new company today and I needed to build like a backend API that's just doing some CRUD, I'd probably write that in Go. But if I was going to build any component that lives in like a customer infrastructure, right, like an agent, for example, which we'll talk about here in a second, I'm going to build that in Rust because I need to make sure it's going to use the least amount of resources for my customer as possible because customers have to pay to run your application code. And B, it's going to be as safe and as crash-free and error-free as possible. And Rust gives you a really big advantage in that direction compared to other languages.
Exactly. Good. Now, okay, so I want to look at the code. I want to look at the code what you wrote here because you may see a call happening here. There's a 127.001. Like, what are we calling something localhost? This is a Lambda function.
We're going to start. Yes, exactly, Darko. We are going to wade into the world of Lambda extensions and sub-processes in Lambda. So a Lambda extension is a specific type of binary that AWS supports that can run alongside your Lambda function. And this is tiny and it's not the right document. Okay. So
there we go.
Here we go. This is what I wanted to show you. So what it does is they provide, Lambda itself provides an API that allows someone like Datadog to run alongside your code. And we can then communicate back and forth. And the way we do that is, a couple of ways. You can do that on any network connection. You can use like a Unix domain socket. You can write straight to the processor, write to a file, and read from it if you want. But there are two processes that are running in the same sandbox, in the same Lambda sandbox. So they can communicate on any matter of protocols. OpenTelemetry, I don't believe it supports Unix domain sockets yet, or UDS. So we do have to go into the HTTP stack, which is going to be a little slower. Not bad though, because there's no NAT, there's no network. It's all on the same kernel, all in the same system. So it's still quite fast.
Nice.
And I'll show everyone how we add that in a second. That'll go in our infrastructure.
Yes.
So there's two more parts to this. We need to create. So these are not Lambda layers. These are tracing layers. So we'll do tracing, OpenTelemetry, and then layer Copilot. I think is right here. Yeah, it is. So this is just saying, hey, we want to use this tracer. We're gonna build it into this layer thing. We can use a logger format, and I don't actually. Do we? We may not even need the logger for that. Oh, actually, we should. We should use it.
Let's get it logger. Yeah.
And then we don't need. This is layer. Okay, so we actually want something different. Copilot's close, but not. So these are just a couple of arguments we can say that will format our logs differently. So these are logs that are going to get shipped to Datadog, and then we want another formatter as well. Format layer. Hey. Tracing subscriber format layer, and then this is just going to do the dot with target false, and then we're going to do that without time because we're going to get time from Lambda itself. Okay. So these three things are all set. We've got we've got the tracer. We pass the tracer into the telemetry layer, and then we've got two other layers: the logger and the formatter. So now we can just register it. Default, and then dot with, and this is something called a builder pattern. You'll see this a lot in Rust. You're gonna, it's just like a big part of it. oopsies.
So when you're creating something, you have a bunch of these like dot notations where you're adding different parameters to a specific thing you're running or creating or an object, whatnot. And this is called the builder pattern, where you just kind of add different features to it. Beauty about Rust is that you can put it on multiple lines. It can only be on the same line, but you should probably do it on multiple lines for visibility.
Yeah, exactly. And I spelled this wrong. Okay, so one other advantage of Rust is if this code compiles, it's generally going to be correct. It's generally going to work. Hold me to that here as we move on from the code section. So you can see my editor. There's no errors here. The editor all looks good. So let's go back to our infra because we have to add some environment variables.
So what AJ did here, he basically kind of created a boilerplate required for enabling tracing with Datadog for this specific application. Just basically telling it, before you run any of the actual main code, set this up. So
yeah.
Okay.
And all I'm saying is you can find the agent here, and here's how you want to configure it.
Yeah.
And then this sets the rest of the tracing things. I want it to sample always. I want it to use a specific random ID generator just because the default one, I think that by default it samples quite heavily. So we don't see every trace, which for a demo we don't need. Install simple. All that's saying is we know there's one runtime. It's the Tokyo runtime. You can do what's called a install batch if you want to install it to multiple runtimes, or if you're going to mix like a Tokyo runtime with the native async runtime. And then the rest of these are just configuring how we want the data to look. So that's it. There's two functions, right? Main and function handler. So let's go back to the infra. We got our stats. We don't have our stats. Should we do the stats quick too?
Yeah,
so
let's do the stats,
So let's actually do. We should do something. We should do something useful. So I think we've got simple let me pull up this from my notes.
So while you do that, I'm gonna actually just respond to something Sam Bear is asking here. Isn't serverless the opposite of customer infrastructure in this example? Because you mentioned deploying something to customer infrastructure, you would use Rust. So yes, serverless requires infrastructure no matter what, right? There's nothing to manage specifically. There's no servers, there's no patching, there's no like any of your typical traditional thing where you have an operating system and you work with it. You just deploy it as Lambda function, as API gateways, as event bridges, as all of these wonderful little elements of a serverless system. So yes, they still exist on a customer endpoint if you wanted to deploy it in a customer account.
Correct.
But they're not your typical servers.
Yeah, when I was speaking earlier, what I meant is if I'm going to build something that you have to run on your end, and in this case, it's something like our Lambda extension or our agent is going to run, it's going to be a Lambda layer that we'll use, and we'll apply via that agent thing we talked about a second ago. And I'll show you that in the infra, but that is something that, I write code for, I ship, and then you download and use it. And for that, that's where I really like to have Rust. Okay, so we want to remove the hello world thing. We need another message. We're going to, so this has been great. Thank you, but we're going to remove it.
Okay.
And we're going to make a web request. So let's let client equals request.
So we're using request. It's an HTTP client from Rust. It's basically you're going to make a call to some API endpoint, right? And you're going to return some data back. Is that yes?
Yep. And we're going to do the same kind of thing. Oopsies, that's a new line. So we got this sample APIs, baseball hits. Once again, shout out Benjamin Pyle, hook me up for that. We'll do this get, and we'll do send the request, and then we'll await it, and then we will add the question mark, and all the question mark is doing
is unwrap.
Yeah, it's doing an unwrap. So in the similar way where you'd have like a nullish coalescence in TypeScript, where you can do like, is this null or is this something? This gives me the something, and if it's null, it actually panics. But can we do JSON here? Oh, I don't want to. We'll just do text.
So I wanted to comment. Tony Awad is asking, if you were to start over and learn Rust today, where would you recommend to start? I mean, the thing is, I think both AJ and I have started Rust recently. Like we haven't I haven't been using Rust for the last, I think, 8 months, and that's about it. But I would always recommend the book, The Rust Programming Language. I think that is a very well written book with a lot of great examples. Here's a link to it from Amazon, not affiliated. Sorry for the insanely large link. But it is really, really, really good.
Yeah.
That's a horrible thing.
I am not a book learner. I got to be
You're
honest.
not a book learner. Okay.
I'm a book referencer. I love to have a book to page through it, but I learn by picking a project and building it. So I started building out a couple of simple APIs, and I actually built on stream a CLI called Yoink, which can yoink or copy Lambda layers.
Yeah.
So I built like this little CLI tool.
Yeah.
And it lets me download stuff using the AWS SDK. And that's literally what I was
Love
like,
it.
I'm going to learn Rust this way, and I'm going to build this little, oh, wow, that's way too big. I'm going to learn, these expectations, and I'm going to learn the matching syntax. These are all very Rust-like things, and I picked it up that way.
Same.
So
I mean, I learned project. Yeah. I did start with a book, and I did an hour and a half a day going through like chapters, but like actually being active through the book. So anything they do in the book, I do myself. But as AJ says, take a project, build something that you potentially need, something silly, something stupid, and build it in Rust.
Ideally something you would use. So for me, exactly. I spent a lot of my time, like I said, working with Lambda layers and extensions in my day-to-day work. And the AWS CLI isn't super easy to download them because seriously, it's one little thing. A Lambda layer has a colon and a version at the end, and sometimes like you need to pass the version separately, and that annoys me. So I just wanted to be able to paste an ARN with a version in and download the result, and that's what I wrote. Okay, so we need to do a few things. We need to add an API key.
Okay.
Add environment, and I'll hide it, and we'll use this.
Right. Okay. So
we'll do that, and then we need to we're going to set a service. We expected that, right? We're going to panic if we don't have a service. We can actually do this too. Add environment. This is right. That's fine. And then, yep, we need this dot add, and then dd service. These will all be set for you with our wrapping code. But since I'm writing this from scratch, we have a CDK construct that does all this. But that's today we'll do it by scratch, and we'll call it baseball stats. Okay. So we need to add these few things, and then we need to set what's called a Rust log. This is part of the tracing library. We have to tell it which parts we care about. And then we need to do a little bit of magic. So we recently shipped this Rust-based Lambda extension, and I want to opt into it. So that's what this does here. We're gonna opt into it. This is some top secret stuff you're seeing on stream, Darko.
Okay, look at that.
And then we need to actually add the layer. So here is what it looks like. We have an ARN from our own account with a version. We need to include actually the Lambda layer.
Construct, yes.
Construct. I almost just said struct.
Struct. Well.
Yeah.
So just kind of a thing what's happening here. So AJ is actually adding environment variables to the Lambda function. Each Lambda function has its own set of environment variables. So when the Lambda function executes, these environment variables called dd underscore whatever are going to be available to the function at runtime. And if you've noticed in the code, he sets a couple of variables based off those environment variables. So,
and then I'm just going to hide my screen super quick and export my key because.
Oh no, it's Hunter too.
Dang it! Now I have to rotate it too. Okay. So this should be set. And yeah, everything looks good. Yeah, exactly. So these are all environment variables that are going to go live on our Lambda function. And then we're just adding this little bit of code, this layer will actually add that agent. So we're setting ourselves up in our handler to talk to this API. And on the server side, which is me also on the layer on the local host, we'll get it here. All right, Darko, deep breath. This should do it.
Okay. Let's pray to Ferris. By the way, Chad, do you know the name of the Rust crab is Ferris? If anybody knows why is he named Ferris, let us know.
I got that same error again.
Yeah, do you have to set the environment variables again? Okay.
Cargo release profile override debug. I'm not sure why
Are you using like some sort of a bleeding edge version of Rusty or?
No, I'm not. I think it's actually something I did to the CDK. I tinkered with some internals. Don't be mad, Darko. Don't be mad. I was playing around with something and I was breaking the internals, I think.
Okay.
So I think it's like shelling out and it's not passing the right. Why can't I think of the? It's not passing the right arguments to Cargo Lambda.
Okay, interesting. This. By the way, have you heard about this latest thing coming from Intel, our friends, of their Intel desktop CPUs that are having these issues? Like Like the latest 2 gens of Intel have this whole thing where they just apparently oxidize, and like if you run them too hard, they just kind
Really?
of freak out. Yeah, and it's like a hardware bug you can't fix. So I haven't realized that, and when I ran compilation of some of my packages, it would randomly fail the compilation, just like
That's
in
so
the middle of
weird.
compilation, just die. But then I
That's
ran it
so
again, and
weird.
it's fine. So yeah, I've realized I have to complain to Intel now about my CPU being busted.
That is.
Um,
I
so
think it's every developer's nightmare to run into a bug that you can't reproduce, and you're just like struggling with, and then it turns out to be like a hardware problem or like a compiler
literally hard.
problem.
Yeah,
Where you're like, you're so conditioned after. I mean, I've been writing software for 12 something years, and
yeah.
I'm so conditioned when someone's like, I think there's a compiler bug, to be like, there's not a compiler bug.
There's not a compiler. Yeah, exactly.
It's you. If you're wondering if it's you or the compiler, it's you. So
Okay.
so I have to, I have to caution myself and know that like there are compiler bugs. There are hardware
Compiler
problems like
bugs.
this. There are, weird side channel attacks and bugs that happen. And frankly, that's just life.
Yeah. Although I did used to work in AWS Premium support, and I had a customer that would call up and say, "Hey, Darko, I think Elastic Beanstalk is broken," and I'm like, "It's not. It's you probably, because if it was broken, everybody else would be having the same issues."
Yeah.
Until it actually was broken, so I'm like, "No, it can't. No, it must be your problem." Turns out the system was busted. Um,
No.
okay, look at that. Look
Yeah,
at
so we have some data. This is all
that.
that data back from that API. It's because I'm sending it as text, not JSON. My formatter isn't picking it up. But that's what it looks like. We're getting all these hits and all these records back. I want to make sure so we're getting some data. So, oh wow, okay. So let's look at these last 15 minutes. Let's make sure that we have some data. Okay, we're getting data. Baseball stats. Okay,
Nice.
this will be tricky to show this zoomed in, but I want to, I might zoom it in and then make it wider because it's very goofy when it's in this way. Okay. But we can see that we've got all of our logs here from a couple different requests. We've got our durations, our runtime durations are showing. This init duration is 118 milliseconds all in, including tracing, including logging, including setting up everything up for Datadog. Pretty decent here. And then it looks like it took us about 180 milliseconds actually to send it to the back end. So the actual runtime, was 500 milliseconds, and then it took us about 200 milliseconds to send some data. Let's see, do we get some traces?
I want to see how long the HTTP request took. So that's my.
I have to turn that on. I don't think I'm
okay.
gonna have to have that traced yet. So right now, I think we'll have to start a span for that. But yeah, so you can see that the entire handler took about 525 milliseconds.
Okay.
And you can also get some information here, right? Like this is the file, this is the line of that code it's executing. This is the version we're all doing. You can see that this is like the information of the event coming in. You can kind of collect this information, then you can see that it's coming from this like open telemetry library.
It's also fascinating because like you see the file src/main.rs, but like we're running a binary. Like
No, we can extract that at package time. So I think part of that's built in. Yeah, that metadata gets like as part of the CDK deployment.
Okay, that's good.
Yeah. So let's see if we can. This actually all worked. I'm amazed. We have 10 minutes left. Should we see if we can trace that request?
Yes, but there's a question for you, Mr.
yeah.
AJ. So Tony says the Lambda layer is developed by Datadog, and the communication with users' Datadog account over HTTPS to record a trace. Does the Lambda function need access to the internet to record traces?
No, it does by default, but you can use like private link if you want to send it over a VPN. So init duration looks crazy fast. Yeah, Tanmay in chat, shout out to your cold starts being a lot faster now.
Exactly.
We found, depending on the runtime, this is like between a 50% and like a 5x performance improvement using Rust from our initial implementation. It's all public. It's all here. This is also, it's a big Rust project right here. You can see all of the lifecycle code, the telemetry, how we handle your secrets, all these different things are all part of this project. And I just merged this yesterday. So like, for example, we're using Tokayo, and we are using a Tokayo select block. So it will actually pull these two features. And one of them is listening for events from your Lambda function. And the other one is just detecting, hey, should we flush some data? Like, is it time to send some data? And we are intentionally like saying, well, let's make sure we look for data from you before we just check to see if it's going to flush. So like active development, open source Rust project. You can check it out. I'll drop the link in YouTube and in Twitch chat.
Thank you.
But yeah, there's a reason. Oh yeah, Andy. So Andy in Twitch, is the Datadog Lambda layer language agnostic? Yes, it is.
Yes.
It's completely language agnostic. It is a sidecar process, so it runs separately from your application code, and it runs in parallel, and it will, because it communicates over HTTP. This will work on any language.
Exactly.
It works in JavaScript and Python. Actually, I've got an example I think from earlier that was in Python.
Yeah, one of the things that you notice here in the actual code that AJ wrote is that it's making a HTTP call to localhost, and as long as you have a language that can make an HTTP call to localhost, you're golden. So
exactly. Yeah. So we actually write the tracing libraries too. So in the Rust case, we don't have one yet. We're using the community supported OpenTelemetry Datadog. In our, and I don't have the JavaScript one handy right now. But in our JavaScript, Python, .NET, Java, they're all supported, and we have tracers for those. Okay, so let's see if we can do this. That's the infra.
Yes. Let's go ahead and change it so we actually in the next 8 minutes we're going to try to implement tracing for the actual HTTP call being made to the baseball stats. So we actually want to see how long that one takes in the overall execution, because this is the whole thing. You're using tracing to identify where the bottleneck is. Maybe that's a very slow API and you need to make sure your application runs better. You go ahead and you just make it faster, I guess.
And okay, I gotta find, sorry, I accidentally pulled that up in my wrong window. I gotta find the docs for this library.
Okay.
Open telemetry crate.
Yeah, so basically, because he's using the open telemetry crate, it uses its own way of doing it, right? Has set up, you have set up like the instrument macro on line 8, which does the whole instrumentation of that function, but doesn't do specific calls, right?
Yeah, and I think we can do this. We can do like a, so we're gonna create a span, right? So we need to grab our tracer and say like let tracer equal global tracer, and then we've got our baseball stat tracer. So that's going to live in like a thread global variable.
Okay.
And then we've got a create a span. We're going to make it mutable.
Mutable span, yeah.
And then it should be tracer.start, fetch stats. That looks good. Thank you, Copilot. And then we can set some attributes if we need to. But I think we can just do span.end at the end of this. The only question, here we go. Okay, yeah, we need to use global OpenTelemetry. Use OpenTelemetry global. Thank you, Copilot.
Thank you, Copilot.
No method name start on tracer. This is not right. We need a few more things. Hold on one second. I'm gonna just copy and paste this from the example code.
Sure.
We don't need a couple of these. Yeah, so we need the span, we need the tracer, structs, and then we don't need to shut this down because we're going to use it again. Okay, this looks like it's going to compile.
Okay.
And let's use span.add. It's set attribute. Hello, and then we'll do chat. Okay, so this is just going to show us how. What did I do wrong? Oopsies. It's supposed to be a value. Sure. Okay, so it's got to be key.new. So this is the typed part, right?
Yes.
New hello, and then we need
value.new.
Is it value.new?
I don't know.
No, it's .string. Sorry, it's not a. Shit. Not bad for a library I've literally never used before. Okay.
Yeah. Okay.
Undeclared. Okay, we have to.
You have to import key.
Which is right up here.
Okay.
So not key. Yeah. Okay.
Okay.
Let's see if Cargo likes this. So we'll do a Cargo. We'll do a Cargo Lambda build. 5 minutes left. Darko, we are racing.
We can do it. We can do it. Well, that's the thing, right? You can do it. It's not that hard.
I'm trying hard and believing myself.
Yes, exactly. You're doing your best. But I would actually encourage people to go ahead and like the next Lambda function you're going to try to build, try to do it in Rust, because it can do so much, right? And again, Lambda functions are just doing a lot of CRUD calls for you, and Rust can do that really, really well. You can do a lot more with the Rust function. You can run Rocket on it, do a whole lot of stuff if you want to be really that fancy. You can even do WebAssembly if you want. But you wouldn't, yeah. But but you can absolutely run your Lambda functions in Rust. It
Yeah.
just takes you a while to get used to the intricacies of Rust.
Try it out.
And
Try
once
it
you
out.
do, yeah, once you do, you'll understand why we love it so much. Why we
It's
are
worth
called
it.
it. Yeah,
It's worth it to learn. And also, I would say, if you're brand new to programming, this all looks really scary and it's really hard. Pick a language, pick any language.
Yes.
Python, JavaScript are both great places to start.
Yeah.
Once you've got a few years under your belt and you've worked with it, these programming languages, they don't all sound the same, but they rhyme, if that makes sense. The syntax is going to be different. Like the actual, words you use to tell the programming language to do different things is going to be different. The libraries you're going to use are going to feel different. They're going to look and be different.
Yeah.
But they, arrays are going to be more or less the same everywhere. Hash maps are going to be more or less the same everywhere. Environment variables, more or less the same everywhere. Those concepts will all be there for you anywhere you go. So that is a key part when you're learning like a second or third language. I think Rust, you'll pick it up.
Yes, I agree. I absolutely agree. And again, if you run into this whole complexity of Rust and say like, this is impossible, just keep going. Use tools, use knowledge, use books, use generative AI to help you get through it.
All right, Darko, it worked, but I orphaned the span. So I didn't parent it correctly. I did my syntax wrong. Hold on one second. I got to figure out what I did wrong.
But we do know that, we know that it lasted 221 milliseconds.
Yes, correct. Okay. I just didn't parent it properly, and I don't know why I did that wrong. But there's something I didn't know in this library where it's just creating its own span off in the ether.
That's okay.
But it can be done. It's here. So that's most of our latency right there is coming from here.
200 milliseconds. Yeah, there you go.
221 milliseconds for the request, and the entire handler took 222. I will find the answer for this. This is just a fat finger somewhere, but I know we have 3 minutes left. I want to make sure chat. All right, ask your questions in chat.
Yeah, exactly. Ask your questions in chat. We have 3 minutes left, but Tanmay is saying Lambda is also built per millisecond. So if you want to lower Lambda build, Rust is probably the best choice. Again, depends on how much you run Lambda functions, right? Like it can be.
Yeah.
It can be a lot of money. It can be almost nothing. So, if specifically for complicated systems, and it's just, as soon as you grow and scale, Rust may be the right choice for you. Rust, or I would say even Go. Right? Again, it's like .NET does a really decent job when it comes to like Rust. When it comes to Lambda functions as well.
.NET's incredibly fast. I think the cold starts are really painful, but the actual application code once it's running, it routinely shocks me how fast in like our benchmarks. How fast .NET as a runtime is to just execute code. It's so crazy fast. It's really good in that respect.
Really good. So definitely try it. Again, simple project, even a Hello World from the
Cargo Lambda,
Cargo Lambda. Now, if you're not a fan of CDK, you don't have to do it straight through CDK. It's easiest to do it in CDK right now. I would assume there's a way to do it in Terraform.
Cargo Lambda will also do it for you. So you can just deploy the function here if you want to. David's got a great video about this. It is just a little like I needed to set some environment variables and add a Lambda layer, and that's not something they support. I could do that with the CLI, but I like it all to be in one infrastructure as code package. So
exactly.
That's why I went this way. But yeah, you can definitely try this out, play with it, and same with Datadog. There's like a 2-week unlimited trial, so just check it out. Like you can see. Here, I'll show the overview for this function we're just shipping. We've got all kinds of metrics coming in here. We can show you, how long these are taking. You can see where we, added this like request that's coming in and why it's taking longer. You can see that's like, 118 millisecond in iteration. I know this is probably getting cut off. I promise you, it looks better on your screen at home.
Yeah, no.
My designers are going to be upset with me. But we also,
looks amazing.
We'll grab logs from here too. You can grab all the logs from your function execution, your metrics as well from all of these different, we're tracking how many cold starts you have. Are you having any timeouts or out of memory errors? How many invocations? Obviously no errors here, but you can see like your init duration kind of changes a little bit in the 100 milliseconds, pretty solid. If there were any errors, they would pop up here. If we configure deployment tracking, you can get this too. And then from here, we can also get configuration information. This is all being done in a 128 megabyte Lambda function. And that's one of the reasons I like Rust.
That is insane. Friends, observability is one of the key aspects to a good application, so do not skimp on those tools. Definitely going to be part of your whatever you're building. Definitely going to be part of it. So check out Datadog. Check out the Datadog Lambda layer for tracing as we set up here. Check out Rust on Lambda. It's a fascinating way of doing some serverless stuff. But also Do check out AJ on all the socials.
Oh, yeah, I'll plug
Twitter,
it quick.
yeah, Twitter, LinkedIn, MySpace.
You can find me on LinkedIn. You can find me on Twitter. You can find me. I'm on. I think I've commented both in Twitch and YouTube. So you can just hit my name and hit the follow button. Really appreciate it.
Yes.
I'm
AJ also
YouTube
live
and
streams
Twitch.
as well. So if you want to see some live streaming Rust goodness, definitely AJ is the person to follow. And also, do not forget to come back here next week, as there's more serverless office hours coming your way. Oh boy, AJ, we ran through it.
Write some Rust. Get a split keyboard. Have fun.
Get a split keyboard. Remember, with a split keyboard, your code is going to be 20% faster.
Yeah. The demos all worked first time, except
the demos all worked first time. That's the latest. That's the latest feature coming out of a split keyboard. Oh my god. Okay. Stay tuned for Becoming Awesome. We have some amazing folks coming up. So if you want to hear stories from AWS, from Amazonians, stick around. AJ and I are going to go offline and do things. And
back to work.
Back to work, as they say. Bye.
Bye, everyone.
End stream now.